Dear students, welcome to another lecture in industrial engineering. Today, let us discuss about the critical path method. Now, critical path method is also called as CPM. It is abbreviated, and it is a very well-known method to for project management. Now, the critical path method, or the CPM, is a step-by-step project management technique to identify activities on the critical path. You see, if there are a number of activities in a project, this project can be any project. It is not only for mechanical engineering that we use or for production in the industries, but also it can be used for any project. It could be electrical projects, civil engineering projects, or any other project also it can be. Okay, this critical path method, CPM method, can be used. So here the definition says it is a step-by-step project management technique. So those people who are studying project management, they study this. Okay, but even in mechanical engineering, even for our process planning also, we can use this critical path method, CPM. Okay, and this is used for identifying the techniques on the critical path. So there is a certain thing called as critical path. Now that critical path we have to find out, and we have to identify the activities that are falling under the critical path. See, actually there are many activities in a project, but some become critical and some are non-critical. Okay, see, now the critical path here, what they're saying is the critical path is the path with longest project duration. See, once we find out this critical path, then we will know what is the project duration. And so the critical path is the longest project duration. Okay, and that will be the total project duration. Okay, like that. See, this is a very interesting topic. Even when I was studying bachelor's of engineering, we had a subject called operations research. In that operations research, this is one of the topics, and at that time we used to study two topics in this. It was called network analysis, and in that this was called CPM, critical path method. Another was there, PERT, P-E-R-T, PERT. Two methods were there. Okay, but now we are studying only the CPM method. Okay, so see, when you go to higher studies, you may be exposed to other methods on the network techniques. Okay, now the critical path method is another definition here. It is the sequence of scheduled activities that determine the duration of the project. See, now till now what you have understood, this is for a project, and we are using this technique for the management of the project. And in this there are many activities, and there is something called as critical path, and all the activities that fall under the critical path are the critical activities. Okay, now the sequence of scheduled activities that determine the duration of the project is the critical path method. These scheduled activities must be performed in a specific order. You see, they will have precedence. That means first you should do something, next you should do the second thing, then the third thing, like that. See, you from a specific order you heard. Example, in order to build a house, the walls cannot be constructed before digging and making the foundation. You see, it is but natural. You see, without the foundation you cannot build the superstructure. Okay, so first you have to lay the foundation. Okay, that should be the first step. Similarly, even when you are doing some machining on the on the any machine tool. You see, there are certain activities which first you have to attend to, and then later only you have to do the other things. Okay. So next bullet point here, each activity. Now there we are calling something as activity. You see, that we will define all these things. This also we will define in this CPM what is an activity. There is something called as event. There is an event and there is an activity. Now they are talking about activity. Okay, each activity takes a different amount of time and resources. Now digging the pit for the foundation is an activity, making the foundation is an activity, building the walls is an activity. See, these are all activities which take different amount of time. This may take just one day, digging with the JCB if you are digging, and laying the foundation may take 1 or 2 days, 3 days, and walls it may take few more days, like that. You see, they all have different amounts of time and they all need different resources. Okay, for digging you need a machine like JCB. For laying the foundation you need cement and concrete, sand, and all such things, and steel. Okay, then from building the walls you may need bricks, cement, sand, and other things. Okay, you see, different resources are there and different times are there for each activity. The total time taken to complete the sequence along this critical path would give an idea of the project's minimum duration. You see, if you are building a building, you see, there are so many activities involved. Okay, when all those activities are completed, then only we can say the building of the house is done, the project. And we will be able to say, if we add up all those things, then you will get something called as the project duration. So if you are as a builder, you have to give certain timing for your for the buyers. You say at that time project duration is, you will say it is 6 months, it is 9 months, it is 1 year, depending upon how big the project is. Okay, in the engineering field, in a mechanical engineering field, in our production shop floor, see, it may be few minutes, it may be few hours, few days, like that, depending upon what the project is. Okay, so critical path analysis. Now when you study and analyze that critical path, it becomes critical path analysis. It is commonly used with all forms of projects, including construction, that is what, civil constructions, aerospace projects, defense projects, software development projects, research projects, product development projects, engineering and plant maintenance projects, and many other such things. For all these things, this method can be used, critical path analysis. Any project with interdependent activities can apply this method of mathematical analysis. Okay, now next, the terms used. Now I just said we'll see the definitions. Now the first definition that we see is event. Event, it represents the start of an activity or the end of an activity. You see, like you started digging the foundation, that is an event, and you finished digging the foundation, that is an event. But in the middle, what you are doing, digging, is an activity. So that means what? If there is an activity, on either side of it there will be events. Yeah, I will show you one slide in which you can see this. Yeah, see here. Now here 1 is an event, 2 is an event, and this arrow represents an activity. Okay, this is start the foundation, finish the foundation. Okay, this is one is start the foundation, two is the finish the foundation, and A is the digging foundation. This can be some other activity, this can be some other activity. Okay, now you understood what is an event. Event is start or end of an activity. Okay, it does not consume, and another characteristic of an event is it doesn't consume any resources and does not have any duration. You see, start something, for that do you require any time or any resource? No. Okay, event is a point in time, begin an activity, end an activity, that is an event. See, it is represented by a circle called as node. I showed you just as a one circle with a number inside. That is how it is represented. Now next is activity. Activity is a part of a project which requires time and resources for its execution, whereas event is a just a point in time, whereas this takes time. That means there is a duration. Okay, it requires time and also it requires resources for its execution. You see, if you are digging, you need JCB, you need diesel in the JCB, and like that some resources are required. Okay, or if you are digging manually, workers will be required, like that. An activity is represented by an arrow. See, whereas event is represented by a circle, small circle. Activity is represented by an arrow, the tail of which represents the start and the head represents the finish of the activity. Okay, so the tail means the back side and the head means the arrow side. So the arrow side shows the finish and the back side shows the start. Okay, now examples of activities are given. Running a race is an activity. Now 100-meter race is there. First, what they do with the pistol, they fire. When the firing takes place, that is an event. But all these people are running, that is an activity. And when they go and touch the ribbon at the end of the 100 meters, okay, that is the end. Okay, so start, end, and the middle is activity. Okay, start and end of race are events. Okay, and running is the activity. Now start painting is an event. Painting a wall is an activity, and end painting is again an event. Like that it is. Okay, so these are events and activities. You remember, event is just a point in time, whereas activity is a duration of time. Event does not require any resources, activity requires resources. Okay, now next, network. Actually, many people study this as network analysis, but here no, we are just studying one topic like CPM. So we didn't give the title network analysis. Okay, now network also, let us see what it is, the definition of it. It is a representation on various activities and events in a logical sequence. Network also demonstrates the interdependence of events in a project. Is if there are a number of activities, certain things depend upon others. Like if you want to lay the foundation, first earth should be dug, pits should be made. Okay, that is a dependence. See, you cannot lay the foundation till the digging is not completed. Okay, so there is an interdependence or prerequisite. Okay, or there is something called as precedence. Okay, now another definition is dummy activity. You see, dummy activity, this is an activity that does not consume any resource, but it is a dummy activity. Actually it is not an activity, but only we have to show it with a dotted line instead of a continuous line of the arrow of the activity. Dummy activity is shown with a dotted line arrow, and it doesn't require any resources. But why do we show it? We only show it so that this interdependence can be clearly understood in the network. Okay, now next, now there are certain rules for network construction, rules of activity on arrow network construction. Okay, following are some of the rules that are followed while constructing a network. Now in your exam you may be asked to construct a network. Okay, so now let us see what are those rules. In a network diagram, arrow represents activities, circles represent the event. The length of an arrow is of no significance. It doesn't mean a long arrow takes more time and short arrow takes less time. Arrow is an arrow. You see, it only it shows that it is an activity. In the length of it doesn't matter at all here. Okay, but which is the long activity, which is short activity, that is represented in some other way, not by the length of the arrow. That is what we are saying. Okay, now the second point, each activity is represented by one arrow only. If an activity is there, one activity is there, so that should be shown as one activity only. We cannot show part of it here, part of it somewhere else. Okay, we have to show by one arrow only. Okay, say like building of the walls. It is a, you see, it may take many days for building of the walls. Okay, but it is one activity, so it will be shown by one arrow only. Okay, every activity starts and ends in a circle called as an event. Okay, this is so every activity, we cannot put an arrow without a dot at the beginning or at the ending. Okay, that dot or that circle is an event. Okay, next rule is a network should have only one critical event and only one terminal event. Not critical, one initial. A network should have only one initial event and only one terminal event. See, that means this network should have, at the beginning it should not start with two circles. It should always start with one circle only. At the ending also, finishing also, it should end with one circle. You cannot keep two branches under two circles. Okay, like let me show you. You see, as this is starting with one circle and this is ending with two circles, it cannot end with two circles like this. It can here three circles. It should start with one, end with one. Okay, that is the rule that we are saying. A network should have only one initial event and only one terminal event. Okay, then another rule is any event cannot occur until all its incoming activities there been completed. Any event, see, suppose, as we show here, suppose this event E is there. Event, when will it finish? You see, now there are two activities at the end of which this event is being done. See, now this activity is carried out, finished, but this is taking more time. But this event E will not complete till both are completed, both these activities are completed. That is what this rule number E is saying. Any event cannot occur until all its incoming activities have been completed. Okay, next, now there is a simple problem here. This is only for a practice so that you may understand how to construct a network. Okay, this is a very simple problem. Problems won't be so simple. You will have to find critical path and other things, project durations and other things which are not given here. And you should note this, the title of the title here in the top cell. It is said event, it is not said activity. Event, that means we are only talking about these circles. Okay, now these are events. In some other table, no, you may find here activity, so don't get confused. Events are different, activities are different. Okay, now event. Now we have events A, B, C, D, so on till I. Okay, and the next column, predecessor, is given. See, what is the predecessor for A? Nothing. That means A can start anytime. What is the predecessor for B? A. That means B can start only when A is completed. And what is the predecessor for C? A. That means, you see, once A is completed, both B and C can start. Okay, like that. Now let us see. Start means, see, when A is okay, actually, we don't draw networks with events, we will be drawing with activities. But anyway, this example is given like this. Let us see how to draw the network. Now, the first, how will we start? As seen from the table, there is no precedence activity for A. So the network starts with event A. See, here we started A. Now on A, both B and C are depending, so you can put like this, B and C. Okay. Now these three lines, three rows of data we have represented here. Okay. There is no problem in this, no? Okay. Now let us move to the next one. Here, D depends on B. Okay. And E depends upon C as well as B, and F depends upon C. Now these three rows, let us see. Event D and E are based on event B. So from B you can take D and E. Okay, and E and F are based on C. So E and F. Now when you are drawing, first you should draw a rough figure, because sometimes you may take this as F and this as E, and then there may be some confusion. So because now E is depending upon C as well as B, no, that should be drawn in the center. Okay, so now you will get the diagram like this. D is depending on B, E is depending on B, E is depending on C, and F is depending on C. Okay, till now, till this, here we have come. Now next, let us see. Now G is depending upon D and E, and H is depending upon E and F. These two lines, let us see. G is depending on D and E. Now D and E are here, so G you can draw here. And H is depending upon E and F, so E and F are here, so you can draw here. This is all the same network diagram, it is only shown little by little. Okay, now finally I depends upon H and G and H. So G and H I will be, see, now the rules were, it should have one initial event and one terminal event. Terminal event means last final event, initial means start event. Okay, one start event, one end event are there. Okay, These arrows are all activities, these circles are events. This is how a network diagram is. Now we talked about something called as dummy activity, and that dummy activity we have not shown here because it was not necessary, but in some other thing it may be necessary. Okay. You should solve some more problems to understand. We'll see if I can take either today or tomorrow. Okay. Now coming to the analysis of critical path. Now following factors should be known in order to prepare the project scheduling, or in order to prepare the or to analyze the critical paths. Say first, the total completion time of the project. How many days or how many hours or how many minutes this project is taking. It is the total time required for the completion of the given project. This should be known, this factor. Okay, next, earliest and latest start time of each activity. Now how many activities are there? So many activities, earliest start time and latest start time you should know. Then critical activities and critical path you should know. Then float for each activity you should know. Now what is the earliest start time, latest start time, earliest finish time, latest finish time, what is the critical path, what is float? These all are terms which we should know the definitions of. So now let us see the definitions of those things. Now first we talk about earliest start time. Earliest start time, EST. Now this is the earliest time an activity should start without affecting the project duration. Now what is the how early you can start this activity? That is the earliest start time. Suppose you want to study in the morning. What is the earliest time you can start studying? Suppose in your house there is a rule, your father has put a rule that nobody should rise up before 5 o'clock. So what is the earliest start time that you can start? 5 o'clock. As soon as you woke up, you took the book and started studying. That is the earliest start time for you. Okay, but some people say, oh, first I will brush, I will get up, I will do some exercise, and then I will start at 6 o'clock. You can start. Okay, it is not that you should start at 5 o'clock. If you are starting at 5 o'clock, then you can call that the earliest start time. The earliest, the first thing, when is the the earliest time that you can start? That is the EST. Now latest start time. You see, latest start time means, you see, suppose you should study 2 hours. Either you can start studying at 5 o'clock and finish at 7 o'clock, or you can still start later and finish. But suppose you have a rule in your house that at 8 o'clock in the morning you will be served breakfast. Before that 2 hours of study you should finish. So your earliest start time can be 5 o'clock to 5 o'clock, and the earliest finish time will be 7 o'clock. But you will say that I will do other things and then afterwards I will do. Then the latest start time, because 2 hours you have to study and breakfast is at 8 o'clock. So what is the latest start time for you? So 2 hours before 8 o'clock. That means 6 o'clock is the latest start time. Did you understand? That is LST, latest start time of an activity. And why latest? Because the project completion should not be affected. You see, suppose 8 o'clock is the breakfast time. It is a rule fixed in your house, and you don't want to break it. Then the latest start time is 6 o'clock. Okay. Now earliest finish time. Earliest finish time means, see, if you have started with the earliest start time, then you will have earliest finish time. Suppose 5 o'clock you started, then 7 o'clock will be the earliest finish time. So now how will you arrive at earliest finish time? Now earliest finish time is earliest start time plus the duration of. Now the earliest finish time is the earliest start time plus the duration of the activity. Duration of the activity will say Tij. T stands for time, and I and J, this should be in suffix actually. I is the, I can be 1, J can be 2. That means, from one event to second event, the activity time is T, like that it is. Okay, suppose your study time is 2 hours. This will be 2 hours, and the earliest start time is 5 o'clock. 5 plus 2, that means 7 will be the earliest finish time. Okay, now what is Tij? Tij is the duration of activity. Okay, now what is the latest finish time? Latest finish time means, what is the latest finish time in our example that I have told now? Your latest finish time is 2 hours from the latest start time. That means if a latest start time is 6 o'clock and 2 hours is the duration, then your latest finish time will be 8 o'clock. Okay, like that. So how you can put you can form an equation like this. So latest finish time will be equal to latest start time plus Tij. Okay, LFT is equal to LST plus Tij. This formula is not given, that can be written here. Okay, now you understood the 4 times like this: earliest start time, earliest finish time, latest start time, and latest finish time. Okay, now let us see the definition of critical path. Now what we are saying, critical path. Now critical path is, it is the sequence of critical activities between the start event and the end event of the project. That means, actually we see like this, there is a network. In this network, see, this will be a critical activity, critical event, and this will be a critical event, because the critical path always starts from the beginning and goes till the end. Now which route it takes, whether critical route is taking this route, critical path is taking this route, or it is taking this route like this, going like this and like this, or it is going like this and like this, or it is going like this, or it is going like this, we don't know. See, that's what you have to find out. It depends upon any loose time those activities are having. Okay, see, that we will see when we solve some problems. Okay, this is critical in the sense that if execution of any activity of this sequence is delayed, then completion of the project will be delayed. A critical path is shown by the thick line or double lines in the network. Suppose if this A, B, D, E, I is the critical path, then you show with a double arrows like this. Okay, here you have to show. Otherwise, no, you can show with thick line, dark lines here. The other activities will be thinner lines. Okay. So the critical, why they are critical? Suppose the critical path activities are delayed. Instead of 2 hours, you have taken 3 hours. Okay, well, due to whatever reason. So that project duration will be now extended by that 1 hour by which it was delayed. So that's why the critical activity matters. Okay, but other activities which are not so critical, if you delay a little also within that loose time that you are having, which is called as slack or float, okay, the project will not be delayed. Okay, next let us see. Now critical activities, the critical path of the network gives the shortest time in which the whole project can be completed. It is the chain of activities with the longest time duration. These activities are called as critical activities. Okay, critical path gives you the shortest time in which the project can be completed. Okay, then now let us see about the loose time. The loose time is called either float or slack of an activity. It is normally of activity, not for event, because event is a point in time. It is okay. Now the float or slack is the free time. The free time, the length of time in which a non-critical activity and event can be delayed or extended without delaying the total project completion time. Okay. Now, in our example of your studying 2 hours in the morning, okay, you are getting up at 5 o'clock, your breakfast is at 8 o'clock, 2 hours study time is there. So there is a free time of 1 hour. You are free to choose, either you can start at 5 o'clock or you can start at 5:30 or you can start at 6 o'clock. You are free to choose. Now there is something called as free time or float or a slack of 1 hour. Okay. Now slack of an event. Slack of an event is the difference between the latest occurrence time and the earliest occurrence time. Okay. You see, the occurrence, no, studying can, start of the study can be at 5 o'clock or at 6 o'clock. So what is the slack of that event? It is 1 hour. Okay, that's how it is. Next, float of an activity. Now here is the float of an activity. Here also is the float of an activity. Okay, it is the amount of activity time that can delay activity without delaying the project completion time. Float is calculated as the difference between LFT and the EFT of an activity. Latest finish time and earliest finish time. The difference of this is the float, okay, or the slack. There are three types of floats: total float, free float, and independent float. Now total float, it is the difference between the maximum time available to perform the activity and the activity duration. The maximum time available, okay, let us understand what it is saying. It is the difference between the maximum time available to perform the activity and the activity duration. Now in our example, we were having maximum time available is 3 hours and activity duration is 2 hours. So what is the float now? 1 hour. The maximum time available for any activity is from the LST to LFT, earliest start time to latest finish time. So now in that example, earliest start time is 5 o'clock, latest finish time is 8 o'clock. Okay, this is the maximum time available, and it is also the difference between its latest start time and earliest start time. It means, what this total float is, this latest start time is earliest start time. Okay, now let us see what is free float. It is that portion of the total float within which the activity can be manipulated without affecting the floats of subsequent activities. It is computed by subtracting the head event and the total float. Now this free float is that portion of the total float within which an activity can be manipulated without affecting the floats of subsequent activities. You see, this free float, no, you see, actually suppose there are branches in the network, and the through two branches, one we are reaching one event. In that case, no, after that event, what all activities are there? They are called subsequent activities. Okay, so those activities, subsequent activities, will not be delayed. So so how much time is there for us to delay? so that the subsequent activities are not affected. That is called as free float. See, if you want to give that is, you have to compute by subtracting the head event from the total float. Okay, this way you can find out what is the free float. Now the third type of float is called independent float. It is that portion of the total float within which an activity can be delayed for start without affecting the floats of preceding activities. Now in the previous thing we saw subsequent activities. Now here we are seeing preceding activities. See, for an event, okay, before that what activities are coming are preceding activities. Those things should not be affected. Okay, so what is that portion of the total float within which the activity can be delayed so that the preceding activities will not be affected? That is called as the independent float. And if you want to compute that, you can compute it by subtracting the tail event slack from the total float. Okay, this is how it is. Okay, I don't think at diploma level you will be calculating all these values. Okay, but just know that there are 3 different types of floats. Okay, now is it normally I've shown you as just before closing I will show this much. Normally the tables, the question will be like this. These will be the activities A, B, C, D, E. Okay, then their immediate predecessor will be like this. Okay, A, B, C are not depending on anything, and this D is depending on B, E is depending on A. Now these are not events as in the earlier table. These are the activities. Activities means this A will not be in the circle, but A will be here. This is the activity. Now this is the activity A. So now you are you make a circle here and here. You can call them 1, 2, and between 1 and 2 is A, 1 and 3 is B. You can construct the network diagram in this way. Depending upon, actually this is not complete thing. This is not complete. Actually, if it is complete, no, it should have been like this. Yeah, it should, according to the rule, how it should have been. I'll show you how it should have been. If I can minimize this, yes, yeah, I'll show you like this. Yeah, see, suppose this is our thing. Now to satisfy our rule, what we should do is, I will bring this down like this. Okay, I will attach this to here, and this circle will not be needed, and this event I will, sorry, this one I can bring it here, and this is not necessary. This I will bring here. See, now this is a C will go here, this is E, and E will come here. Okay, now you understood how it is. See, if it should start with one event and it should end with one event, now this will be like this. Okay, this is how the network is constructed. Okay friends, today we'll stop here, and tomorrow we'll see further more about critical path method, CPM. Thank you.